Yes. Yeah.
Yes, we can see that.
Yeah.
Myself, Dr. Reena Goyal, and I have completed my PhD from CSIR National Physical Laboratory. And after that, I joined as a postdoc fellow at Shibara Institute of Technology with Professor Murlidhar Miryala and Masato Murakami. And today I'm going to give a talk on superconductivity in layered NB2PDS5 compounds. So before going to show the results, first I would like to give brief introduction about superconductivity. Superconductivity is a phenomenon of occurring zero electrical resistance and expulsion of magnetic field, and this phenomenon was discovered by Kamerling Ons in mercury wire uh, in year 1911 with a transition temperature Tc. And after this discovery, superconductivity uh, becomes the most interesting phenomenon in scientific community due to the various interesting physical properties found in superconductors. And these are the hallmarks of superconductivity. One is resistivity of sample almost vanishes, and another one is it exhibits strong diamagnetism. So there are three critical parameters to define superconductivities. One is critical temperature, another is critical field, and last one is critical current. So superconductivity is a fascinating research field with outstanding superconducting properties, and it inspired researchers because of its wide range of applications. Finding new superconductors to add into superconducting family has been a topic of interest in condensed matter physics. So there are two, as you know, there are two main parameters to define superconductivity. One is high to find application of superconductors. One is high critical temperature and another is high critical field. High critical temperature warrants for low operating cost, and high upper critical field warrants for robustness of any superconductor against magnetic field. So uh, NB2PDS5 in this direction. I worked on NB2PDS5 sample, and this sample was discovered by Zhang et al. In 2013. And the structure of NB2PDS5 sample is monoclinic structure with space group C2 by M. The critical transition temperature of NB2PDS5 is 6.1 Kelvin, while yes, the critical temperature of this compound is low, but the value of upper critical field is very high in this compound, which crosses the polyparamagnetic limit. Clearly, from this table, you can see that the decrement of Tc with magnetic field in case of NB2PDS5 in comparison to other superconductors is low. That is 0.27 Kelvin per 10 kiloarstate. That is, there is reduction of Tc with magnetic field is low in NB2PDS5, uh, which suggests robustness of robustness behavior of NB2PDS5 against magnetic field. And as you know that previously in case of LAFePO3 sample, LAFePO3 is a sample with low Tc, but it prompted researchers. Why? Because it has led to discovery of high temperature superconductors. So we can't ignore low temperature superconductor because of various other interesting properties found in low temperature superconductors, like in NB2PDS5. We have interesting properties, that is high upper critical field in NB2PDS5, which is very useful for application point of view. And another important interesting property of NB2PDS5 is the NB2PDS5 fibers can be grown easily in NB2 in case of this sample NB2PDS5. And although the aim of this work is the transition temperature is low, but the upper critical field is very high. And in our knowledge, this is the only superconductor which is very much robust against magnetic field. Therefore, the aim of our work is to synthesize NB2PDS5 sample to check the robustness behavior of superconductivity against magnetic field. And after this, our aim is to present detailed study of this compound if it shows robustness behavior of superconductivity against magnetic field. So the material used for this experiment are niobium, palladium, sulfur, and the characterization used for this experiment are XRD, SEM, TEM, and PPMS. So this is the procedure followed for synthesis of NB2PS5 superconductor. First, we weigh the elements niobium, palladium, and sulfur in a stoichiometric ratio, and then we grind this material using mortar pestle in a powder form, and then we pelletize the powder using pelletizing machine in a glove box, and then we seal our material in a quartz tube. Uh, and after that, after sealing, the sample was kept inside the furnace for completing the reaction. And this is the temperature curve followed for synthesis of this NB2PS5 sample. First, we increase the temperature by with a rate of 2 degrees centigrade per minute, and then we hold the temperature at 850 degrees centigrade for 48 hours, and then we allowed naturally cool down this temperature. And after synthesis, we performed XRD, and in XRD, from room temperature XRD, what we found, we have fitted room temperature XRD using ritual refinements, and these are the lattice parameters found for NB2PS5 sample. And this is the structure drawn using Vesta software, using the parameters obtained from ritual refinements. And what we found that there is a chain of PDS along B direction. And this is the SEM and TEM studies of NBTPDS5 sample. SEM shows the layered like growth structure, and while TM shows, here you can see that several grain boundaries in microstructure appeared as dark thin lines. And inside A, here it shows the atomic arrangement of set of crystallographic planes with interplanar spacing 0.33 nanometer. And here you can see from this region B, you can see the interplanar spacing is 1.5 nanometer, and this is the SAED pattern from this figure, from this region B. And it confirms, here you can see that there are two diffused ring, which confirms the overall microstructure is layered with columnar chain-like structure, chain-like appearance, however, due to the presence of elongated grain boundaries. And these are the, after structural characterization, we performed the electrical resistivity measurement to check whether it is superconductor or not. So what we measured electrical resistivity, rho versus temperature, and in a high field you can see that this sample shows metallic behavior, while it's the zoom, this is the zoom part of this curve. And here you can see that it shows superconductivity with onset 6.6 Kelvin, while the TC at rho equal to 0 is 6 Kelvin in this case. And here you can see that this is the temperature dependent electrical resistivity at different magnetic field. And here you can see that with increase of magnetic field from 0 to 12 Tesla, TC reduces from 6 to 6 to 2.6 Kelvin. That is, it shows robust superconductivity against magnetic field. And from this measurement, we found that the value of upper critical field is is 191 kilo arrested using WHS formula minus 0.69 TC DHC by DT. And this value clearly above the polyparamagnetic limit, which is defined as 1.4 TC, in this case 90 kilo arrested. And this is the magnetization measurement, and this is the DC magnetization measurement, which shows the onset superconducting transition temperature at 5.8 Kelvin, and while the real part of AC susceptibility also shows the transition at 5.8 Kelvin. And the peak in imaginary part of AC susceptibility occurs at a point where magnetic field just reach at the center of sample. And this single sharp peak is an indicator of better grain coupling in NB2PS5 sample. While the inside of this figure, you can see that at T equal to 3 Kelvin, when we increase the magnetic field from 0 to 10 Tesla, still still the real part is negative. That is, it shows superconductivity is the another confirmation of robustness behavior of superconductivity against magnetic field. And after that, we did specific heat measurement to check whether it is a multiband behavior superconductor or single band behavior superconductor. Figure A shows it shows that there is a transition jump from superconducting state to normal state at 6 Kelvin. and normal specific heat has two major contribution, gamma T plus beta T cube, that is electronic and phononic contribution. And it show figure B shows this is the electronic specific heat versus temperature plot. And here you can clearly see that with increasing magnetic field, the transition jump decreases. That is this is the Meshner effect. And here you can see that the shallow shoulder at 3.5 Kelvin has been observed in superconducting region, which indicates two superconducting gap as previously studied in case of MgB2 superconductors. And this is the gamma H versus H curve. And here you can see that this is quasi-linear with clear slope. One is the region from 0 to 10 kiloarsted, and another one is region from 20 to 50 kiloarsted. And this is the electronic specific heat uh, versus T band at reduced temperature, and it has been fitted using exponential function minus delta by kBt. And it has this curve has been fitted using two band models N1C1 plus N2C2, which further claims the multiband superconductivity. And the superconducting gap in this case was found to be 6.4 and 1.9 respectively. And this work has been cited after this study. This work has been cited by Tucson Park et al. In Journal of Physics Condensed Matter. Here in this paper, they showed that they given direct spectroscopic evidence for two gap superconductivity. And after that, after this study as well, NB2PS5 fiber grown by several groups, and they also showed from anisotropic measurement that NB2PS5 is a multiband superconductor. And from magnetization study also we showed that this is the multiband behavior. And this is the isothermal plot in first quadrant. Here you can see where increasing temperature magnetize if with increase in field, magnetization goes in negative direction, and around at some point it start turn upside, and that is lower critical field. And this is the lower critical field versus temperature plot, and it is not fitted using the general equation, which may be due to the multiband behavior of superconductivity in this case. And the conclusion is this NB2PS5 sample is synthesized using solid state reaction route in a bulk polycrystalline form. And the structure is layered structure with space group C2 by M, and it consists one dimensional PDS chain along B direction. And the NB2 PDS5 sample showed superconductivity with onset 6.3 Kelvin and offset 6 Kelvin. Although the TC is low, but it crosses the upper critical field crosses polyparamagnetic limit, which is very much robust against magnetic field. And the specific heat reveals the multiband nature of superconductivity. In this case, the superconducting values found for NB2PD in this in NB2PDS5 compound is 6.4 and 1.9 respectively. Thank you for